What's happening there, YouTube? Genji here, and welcome back to another episode of StarRupture. In the last one, we finally hit our goal of manufacturing RTSC generators, the final item in the Moon Energy manufacturing track, but we have yet to turn in all of the corporate levels for Moon Energy, which is what we're going to pick up on this episode, because while I do want to repurpose a lot of our high-end manufacturing lines in order to make items that are specific to other corporations, I can't really turn those lines off until we finish delivering the rest of the corporate levels for Moon Energy. So I believe we left off on level 12 or 13. Let's go check the corporate terminal. And what I'll probably do is I'll let these run in the background while we go and set up a couple of smaller manufacturing lines for some items that we're going to need a lot of in other, in other corporate tracks. Okay, so we're currently on level 12, or we're delivering level 12 of Moon Energy Corporation, and we have RTSC delivery set up, but they'll also accept anti-radiation covers, which we have available. So what I'll probably do is set up a second OCL to deliver anti-radiation covers, just so we can maximize the number of research points we're generating towards this 658k target for Moon Energy Corporation. And then we'll move on to level 14, which should be cyclotrones, and then level 15, which is RTSC generators. So we have all of our manufacturing that we're going to need for Moon Energy Corporation, but there are also some other deliveries that we can be setting up in the meantime, particularly for Griffith's Blue, which wants some relatively lower tier materials compared to where we're at right now. They want accumulators and reinforced housings, which we should have some to spare so we can start getting through this track that we've let fall behind a bit. But besides that, every other corporation is going to want something. Actually, I take that back. Clever Robotics wants heat shields. We do have heat shields available. That'll get us to level 13. At which point, they're going to want rocket engines and ion thrusters, which is a bit beyond our capabilities right now. But essentially, I've gone through and I've checked what each of the corporations are going to need at each level and compiled a list of all the items that we are not yet manufacturing. And that list totals 25 items. So there's 25 items between us and the end of the game, and we should be able to fly through that relatively quickly considering we did 11 alone in the last episode. We will, however, have to get a few side items set up that are going to require some in-demand items that we can't really spare from our current manufacturing line. Particularly, liquid helium is going to be in heavy demand, which you're going to need some hardening agent for. So we're going to have to set up some extra manufacturing for that because we're not really going to be able to divert any of our existing manufacturing. Just making some pretty critical components that are going to be needed across all the different corporations. So I'm going to go set up our second OCL for anti-radiation covers, and then we're going to go do a little side project on some extra factories. Okay, here are our anti-radiation covers, and from here they're being delivered to manufacture, think of RTSCs or directly into RTSC generators. But one thing I am going to do is, since these are not needed just yet, and they are chewing up a huge amount of our almost end tier items, I'm going to turn this machine off for now because we're going to need a lot of these RTSCs. We're going to need in another manufacturing line. Anti-radiation covers we're going to need to deliver now. Cyclotrones are going to need to deliver before we even get to RTSC generators, so we don't want to consume all of those items before we get to the point that we actually need them. So I'm going to turn that machine off. We're going to put a second, well, I actually have a second. No, this is the one that's delivering RTSC, so we'll put a second one of these down here next to our anti-radiation covers, like so. We'll loop this out, and I believe we should be pretty well backed up. We've got a full stack of 100 here, and then our silo, our storage depot for these over here is almost has 2 full stacks. So actually, I think what I should do is pull these off of this line instead of off of that line there. That way they're not competing. Let's see, can I would need to turn this. Nope, let that deliver. We're going to need to turn this into a rail connector. No. Rail connector, lock RZ right here. We'll connect you to you. And then this rail can feed both RTSCs to this OCL and anti-radiation covers down to this one. So we'll delete this. There we go. We'll set you to deliver to moon energy, anti-radiation covers, and we should have a whole mess of these come flying through. Yep, here they come. Somewhere? There they are. So these should be worth some, what are these worth? 350, not quite as much as the RTSCs, but if we have both of these going at the same time, we're gonna be making some good progress. There's the rest. I'm gonna say we should have a full stack in here. I don't know why it was delayed temporarily, but yeah, 30k, not a bad amount. So while that runs, we should have plenty of time to go work on some side projects. Our extra factories is one thing I want to work on today, but I also want to try getting the Compounder V2 unlocked. It's going to have some pretty critical high yield recipes for some of the stuff that we're going to need for the other corporations. Specifically things like sulfuric acid and liquid helium. So let's, not this, but this. Let's take a look at which recipes we have yet to unlock in the Compounder. So we need superconductors, substance FHS135493, and synthetic protein. So we definitely have the items for superconductors and substance FHS. I can actually steal those off the line and we can just unlock these without necessarily having to set up manufacturing for these yet. But we will need manufacturing for substance FHS in order to unlock synthetic protein, because we need 500 of these to unlock this recipe. We can get started with these two, so let me go grab 300 electromagnets, 400 supermagnets, and 1000 synthetic resin. Okay, here's our first batch, Compounder. We're going to turn in 300 electromagnets, 400 supermagnets, 1000 synthetic resin, and 3000 data points. There's one. Next up, we have substance FHS135493, which is going to require 800 goethite powder, slightly less than 600 sulfuric acid. I guess I dumped some extra in there. And then 400 liquid helium. So we'll go grab those. Okay, next batch. Compounder. 800 goethite powder, 600 sulfuric acid, 400 liquid helium. Oh, and there's the extra 32 that we didn't need. Insert. Okay, now we have access to substance FHS135493, which you're going to have to manufacture in order to get synthetic protein. So let's see. This is made in a Compounder. Let's plop one down real quick and take a look at the recipe. I don't know if we'll have the available resources to make this directly. We may have to set up an additional, like, side factory for this. One Compounder, please. Maybe we can build over water. Substance FHS135493 is 1 sulfuric acid, 3 goethite, and 2 liquid helium. I know we have a ton of extra sulfuric acid and a decent amount of extra goethite powder from me running around just now to gather those up. Liquid helium, though, is at a premium, so we may have to set up a side factory to get a little bit extra liquid helium, which we're going to need in some other stuff as well. So that'll be probably our first thing to work on in this episode, is an extra liquid helium factory. But before we do that, I do want to get one more delivery set up, or potentially two. Well, let's do one right now because we are using those heat shields for something else. So let's get a delivery set up to Griffith's Blue Corporation with probably accumulators, so that can be running in the background, and then we'll work on our extra factory. Okay, I want to say accumulators are made here in our assembler base. It was one of the very first ones, the very first one that we made right here. So let's see, we don't have an extra, nope, we do actually have an extra output from this. So let's grab an OCL V2, plop this down somewhere convenient, right here, run a rail. Aww. Run 2 rails, I guess. There we go. We're delivering to Griffith's Blue. We're going to give them accumulators. And there they go. Okay, let's go figure out where we can put down an extra liquid helium factory. Actually, I have a small change of plan. As I was looking into what exactly it's going to take to set up another liquid helium factory, I realized that we only need 500 of substance FHS135493, and the requirements to manufacture those 500 are relatively small. We only need 500 sulfuric acid, 1500 goethite powder, and 1000 liquid helium, which I was able to borrow from our existing line. So what I'm going to do is just use this temporary setup here, this single compounder with 3 attached storage depots. We're just going to use this to quickly put together a batch of substance FHS 135493. Once I put all of these into their appropriate storage depots, so we have one for sulfuric acid, one for liquid helium. Get that all in there. And then one for goethite powder. Goethite powder. And there we go. So this will spit out 500 substance FHS 135493 for us that we can use to unlock the final recipe in the compounder section of the recipe station and allow us to unlock the compounder V2. Because basically, while I could have set up another liquid helium factory, it's not like we wouldn't use the liquid helium. It would be a little silly to set up a temporary liquid helium factory and then unlock compounder V2s to then tear down the V1 liquid helium factory to build a new V2 liquid helium factory in its place. So we're going to save ourselves a little effort by just making a temporary factory. And as soon as these are manufactured, we'll get these pushed into the machine and we'll work on unlocking compounder V2.
Congratulations.
Hey!
The Moon Energy Corporation thanks you for the shipment.
Well, there's one thing done. Let's take a look. And I believe this gets us... Yeah, the chemical generator. Plus 8,200 power. Let's claim that. So now they want our cyclotrones. So I guess we'll leave the substance FHS running in the background here. Let's see how close we are to complete. We've got almost a full storage depot. We're on our last stack here, and then we need to fill up the internal buffer, and it'll give us 500. So we have a little bit of time to go, and well, I guess let's first plop down the chemical generator. Obviously, oh, it's only plus 400 now, so this was changed. This used to be plus 1,000. So it's been significantly reduced in heat, which is fantastic. And it produces 8,200 power. And this supposedly pulls down... I forget the word for it. There's some kind of chemical that is described as being rich in the atmosphere of Arcadia 7. I believe it's talked about if you, or when you're doing the Forgotten Engine quest. It was one of the things that they were using to terraform the planet. But yeah, this chemical generator is capable of pulling those electrically charged particles out of the air and then converting them into, I guess, power for your base. So we'll break this down. We don't need this just yet, but that'll be definitely be used in some upcoming factories here. So let's get back to our Atlas field base and set up delivery for cyclotrones. Okay, so we're going to destroy this OCL. And I guess we'll leave that OCL there because we're going to need that eventually to deliver our RTSC generators. But we can also use this to deliver our cyclotrones because I believe this this rail here also has cyclotrones on it. Laser emitters right here. We have a pretty good amount of them built up as well. So we'll let our poor anti-radiation shields build back up while we deliver all of these cyclotrones and more. So let's switch this lever here from RTSC to cyclotron. We're going to get 800 a pop. There they go. And there we go. 100 substance FHS 135493 in a compounder. And another 400 in a storage depot. Makes 500 total. And I've already gathered up the 300 organic compound and 700 sulfuric acid we're going to need to turn in alongside of this. Let me break the rest of this down. Okay. Recipe station. Compounder. It's the final one. 300, 500, 700, 4,000 data points. And there we go. Compounder V2 task completed. So let's take a look at our development station. And it's already the first thing in the menu. However, we are going to need 100 quartz ore. I think we might be just shy of that. We've got 86. So either we go out and we kill a bunch of skylisks looking for 2 to 3 quartz drops per skylisk, or we wait until Moon Energy Corporation finishes delivering, because that will give us 70 quartz ore, which will push us well over the line to unlock that. So either way, we'll get a hold of some quartz ore shortly. Now, there is one more thing you can do if you're in a pinch for quartz, although I've been holding off on doing it in my playthrough because it's a little bit exploity. But if you have a cave entrance that's already been grown over because Arcadia has finished regenerating, you can currently toss a grenade down on top of it. And blast open the cave entrance, because this little bulb right here is within the blast radius of the grenade. And normally this is for getting out of a cave. If you're stuck inside after Arcadia regenerates, you can shoot this and it'll open up the vines. But currently, you can use a grenade to hit that from the outside. That'll let you get in and harvest any goodies, any quartz that you happen to find inside. 15. Oh, we're gonna be one short. No. I'm gonna have to go hunt some skylisks for our final one quartz. Wait, no, I'm dumb. We totally have enough. We have 86, and 15 is 101. We have one extra, not one fewer. Okay, well, with that in hand, we're gonna need 50 ignitium as well. We'll split this in half. Give me this. You can take 100 quartz, 50 ignitium, 10,000 data points. Oof, this is getting a little bit concerningly low. I might have to go raid some of those abandoned facilities that I just ran through and skipped all of the corpses and loot boxes that had analyzable loot in it. Because we do still have a few recipes unlocked, and they're pretty expensive recipes. But at the moment, we're worried about our compounder V2, so let's research this. And let's plop one down and take a look at what we can make with it. And what it looks like. Compounder V2. Actually, let's put it next to a compounder V1 just as a point of comparison. Here we go. This should work. I'll just bring it up a bit. Here's a compounder V1 next to a compounder V2. Very interesting dimensions. It's actually a little bit thinner than it is deep. Is that right? We have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7. Okay. Yeah, that's thinner than it is deep, so yeah, that pushes it a little bit past a compounder V1, so this is definitely not going to squeeze into our existing factory layouts, both in size and height. Look at this. What does this offset look like? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 vertical offset to put a second one on top, which you can definitely do, although I don't know if you'll be able to get a third on there, especially with the size of the footprint. She's impressive, though. Can't wait to get this running and see what it looks like. I'm sure it'll just be some more orange smoke pouring out of it, but very cool little diamond-shaped arcology on top of this thing. Definitely borrows most of its design language from the compounder V1. Let's see, we have 3 inputs. So the recipes should still be relatively simple. And those recipes are a pressurized helium that uses 3 helium-3, 3 sulfur ore, and 2 calcium powder to produce 5 every 2 seconds, so that's what, 30 times 5 is 150 per minute, versus the compounder V1. Oh yes, not even in the compounder V1, that's in a pressurizer. Pressurizer. Somewhere. Pressurized helium in a pressurizer is half the helium-3 and sulfur, no calcium powder, but it produces only 30 per minute. So yeah, 5 times more pressurized helium. That's pretty crazy. Sulfuric Acid V2 is 10 sulfur ore, 2 chemicals, and 1 wolfram powder for 240 per minute. So let's compare that. This is every 2 seconds. It's every 2 seconds. This is 8 and 4. This is 10 and 2. So you're basically taking away 2 chemicals and then adding them onto the sulfur ore, which is completely fine because sulfur ore is basically free and chemicals are not. and then you add on top of that some wolfram powder, which is nothing, and you get an entire cargo dispatcher worth of sulfuric acid per minute. Yeah, it's double. It's literally double. Okay. And then the important one, the one that we're going to be setting up here shortly, is not in a pressurizer. We don't need this anymore. It is liquid helium. So base liquid helium is 1 pressurized helium, 1 hardening agent to produce 1 liquid helium every 3 seconds, which is what, 20 times 1, so 20 per minute. And here we have 1 pressurized helium and 1 hardening agent and 1 chemical, which I think we should have plenty of extra now. And that gives us 5 every 3 seconds. So 5 times the amount of liquid helium. So what I'm thinking is we may want to just tear down our existing liquid helium factory, because it's basically the same. We'll use the same inputs that we're already using in our liquid helium factory, but then we're adding on a chemical, which we should have plenty of extra chemicals available at our sulfuric acid factory. In fact, if we replace everything, if we refactorize with the compounder V2, we should be left with not only more product in the end, but also extra stuff that was previously going into the V1 recipes that can now be repurposed elsewhere. So I guess let's break these down for now, because none of that is here. Let's go take a look at our existing... I guess let's start at the beginning. Let's start at the bottom with our pressurized helium factory, and that is... I want to say that's at our plateau, our electric mesa base. So let's head there next. Okay, here's our plateau base. Oddly enough, I hadn't really noticed it until now. I don't know if there was an update since the last time I played, but all of a sudden, this is running really smooth. Like, there's a little bit of, like, frame drop, but there's not hard stuttering anymore. I don't know if they improved something or something was fixed on my end, but yeah, definitely much better behavior this time. Oh, well, I guess we won't refactor right now, but let's just take a look. So we're bringing in, we have 1, I think we might have 2, yeah, I think we have this split in half. So we have 2 receivers full of sulfur and helium-3, those are going into our pressurizers, and we have 1, 2, 3, 4, 5 of these per system, per factory. This is 1 and 1, and this is going to become compounder V2, pressurized helium. This is going to become 3 and 3. So we're using 3 times. Was that me? We're using 3 times the input, but we're receiving 5 times. Oh, we're getting attacked from... They're jumping all the way up here from all the way down there. That's insane. Anyway, I'll deal with these, then we'll come back after the rupture and build. Actually, I think I changed my mind. While I was waiting for the rupture to pass, I decided, why tear down our existing helium production and build a slightly better helium production in its place, when we can keep our original helium production, build a brand new helium production line, and then have that much more helium in the end. So I'm going to tap a couple of these unused sulfur nodes here, just to the south of our Atlas Field base. We're going to need a Rail V3. We're going to need a cargo dispatcher. Way offset, but that's okay. And we're going to need some power. Let's see if I can borrow some power from one of our existing. No, that's okay. We'll give each one its own V2. Solar generator V2. On the side, we'll set this as sulfur ore. We'll call this... Oh god, I don't even know. What sulfur are we up to at this point? Sulfur TX13. So this will be sulfur TX14 and 15. Sulfur TX14. Pulling sulfur. sulfur ore, and this will be sulfur TX15. Okay, and we still have several more. We've got 1, 2, 3, 4, 5 more untapped sulfur nodes here. So let's go find some helium. And we've actually got plenty more here at our base core upgrade base. So I'll slap down... Uh-oh. We got a storage depot in the way. That's okay. I think there's some more on the other side of this. Oh, yeah. We'll slap down a couple more extractors here and get these set up with some dispatchers. This one will be HE3TX19 and HE3TX20. Let's go. And we're going to get calcium from one of these untapped calcium nodes here in our far east location. We have plenty of calcium left here for future factories, but I think it's everything we're going to need to get our compounder V2 online for pressurized helium. So let's go get that set up. Okay, well, I was going to put this in our compounder bay, but that's actually full up on physical space. So I guess we'll put this here in our far east location. We have some flat ground here to start a new base. So if we plop down one of these giant machines, starting, not quite sure, over here maybe? We just gotta leave some space for some receivers, but this is a good start. Let's take a look at this, figure out our ratios. So if we're making pressurized helium, this is every 2 seconds, so this is 30 cycles per minute. So we're going to have 3 times 30 is 90, 90, and 60. So if we take 480 divided by 90, we should be able to fit, I believe, 5 of these in here. 5 times 90 is 450. So if we combine our 2 sulfur rails and our 2 helium-3 rails, plus our calcium powder, this should total, what, 2 times 30, that's 60 per minute, times 5. 300, so we'll actually need 1 additional calcium node, but that's fine because we have plenty, and they're just a short walk away, so we'll get 1 more dispatcher set up. We can do 5 of these. Let's get this set up. So we can do 1, 2, 3. I'm a little bit worried about crushing. That should be fine in the back there. This is a good source of these water... What are these called? Hydro bulbs. And we'll do 1 more here on the back. So there's 5 in a row. They're so ridiculously massive. 5 in a row, and we'll need to squeeze our receivers somewhere. Let's see, we're gonna need 2 for each to combine into 240, or to combine into 480. So we'll push this back. 1, 2. I almost wonder if we should stack these. Unfortunately, it's an odd number. Well, let's see, what does our output look like? So we're making 5 every 2 seconds. That's 5 times 30. That's 150. 480 divided by 150. We can only fit 3 of these on a single rail anyway. So maybe we do 3 and then a second layer and then 2 on the second layer. That'll give us some extra room. So if we delete this one on the end, delete this. We'll take 1, 2, and 3. We'll delete this guy. And we will have to space these out a bit. So we'll put this, lock our Z 1 apart. 1 apart. I'm sure we're going to need just a ton of support, so I'm going to fill in every adjacent space with pillars. There we go. Pillars on top. We need 21. That's going to be 18 and 3. So we're going to need... I guess technically if we raise these all up by 3, then we only need 4 pillars. Probably should have thought of that first. Okay, there we go. 3 pillars on each. Brings us up to a total of 21. We'll put platforms on top of each of these. And then we should be able to lift this up. Oh no, we need one more. Did I miscount? Well, obviously. Okay, so we're gonna need to lift these by one, which I don't know if we're gonna be able to do. We might have to add another pillar, because I think these are pretty much maxed out at +3. 1, 2, 3, 4. Yeah, okay, so we'll just have to have another pillar, which is gonna reduce our overall support capacity. Okay, I think that should do it. I wound up lowering our bottom pillar by 1. Technically, we need to lower it more than that, but if I lower it any more, it's just going to be under the ground. So we're going to have a couple extra spaces, vertical spaces here on the top, and you'll notice that I've added a 4th on here. I'm going to bring this up to a total of 8 of these, because our ratios work out better that way. 1200 per minute is the closest number that's divisible both by 150 and 240, which is the number that we plan to pump into a cargo dispatcher. So this is just a nice, evenly dividable number that we can use both as our input value and our output value, or use with our inputs and our outputs together. So we'll wire this up as 2 separate factories. I'm just going to combine their outputs into a series of, what is that, 5 cargo dispatchers. That should work. I do need to give us a little bit more thermal capacity, though. We're a bit short. There we go. That should do for now. So, let's get this wired up. So we're going to need 3 receivers for each row. No. 5, right? Because we're going to need 480 both. Well, technically we need 300, but the closest we can get to that is 240 plus 240, so it's going to be a full 480 out of 2 receivers each for both sulfur and for helium-3. And I think what we should be able to do is, because these are so deep, can we actually put this too deep? Technically, yes, but I think what's actually more interesting is because these are so tall, is instead of doing this, making these super deep, we can actually just stack these on top of each other. So if we put this back 1, 2, auto-saving, and we put one of these here, we should be able to put another supported pillar in the back here temporarily, raise this by, what, 1, 2, 3? Put another pillar support in, put another platform in, raise... No.
Detected. I recommend finding a safe place.
Raise this up by... Now it's gonna fight me. Why you like this? Go up. There we go. We can place that there, and assuming that those are directly on top of each other, perfect. We can delete this pillar because these are now supported by the adjacent pillars. And then we can put a storage depot V1 in the front. And we can run both of these. They can combine their inputs. 1 and 2. And there we go. Now we have 240 and 240 for a total of 480 into this, which will be more than enough to satisfy our draw of 300, is it? I think that was calculating for 3, so we have 30 times 3 is 90 times 4 is 360, actually. A little bit closer to 480, but that still should be enough with what we're bringing in here. So we need 2 of these and then just a regular receiver for our calcium powder. Okay, back to work. So we need another set of cargo receivers here. Let's see, is this going to extend enough support? No, we're going to have to put another pillar in the back, which is not a big deal. So we'll bring this up 1, 2, 3. 1 pillar, 1 platform, And another cargo receiver. Put a storage depot in front. I hate that the crabs make the same noise as the vermin. I thought that we were getting raided. I was like, that doesn't make any sense. Vermin don't spawn right now, but somewhere in here... There he is. There's a crab creeping around. We'll wire this up. One for you. One for you. And then just a regular cargo receiver. Right here. Buffer in the front. So we're going to need 3 sets of rails because we're at 360 and 360 for each of these. So let's run 3 sets of rails. We'll do... I guess we'll need to use rail connectors for 3. So we'll do... Oh. Down 1, 2. Then down 1. Then normal height. And we'll set up a rail support here. We'll bring this down 1, 2. We'll bring this down 1. And then this at full height, right? I think that's how this should work. This will come down here. This will run to here. Why is that offset? Oh, why are those? Oh no, I put them at the wrong height. I mean, it's not the end of the world. I'll just have to raise these by 1. I aligned them to the pillar supports and not to the... Not to the compounders. Okay, so let's go down 1. This will go default height, and then this will go up 1. To here. There we go. As long as the rails are straight in the end.
Wow.
You?
have fulfilled
Hey!
another order from the Griffiths Blue Corporation.
And there's one of our turn-ins. We can stop crushing our accumulator production. I'm sure that has some downstream effects. Okay, so let's get some power into this. And what better time for some more power to test our new chemical generator. So we're going to delete this. We're going to build... I should probably build a tower of these. We're going to need quite a bit of thermal capacity here. But for now, we'll just slap one on just to keep things rolling. Put these over here willy-nilly. Why is this... One of these is off. Oh, you're off. That's okay. We're going to build a tower. We'll leave it for now. So we're going to chop a chemical generator in. This is going to be... I can't believe how small this thing is. It's a little baby. We'll push this here. We'll need to get this connected to the rest of this. So we'll bring this up to here. And I guess we can just walk this around. Like so. Perfect. Okay. Let's get the rest of these rails hooked up. So we're going to need 3 rails. Starting here. So this is down 1, 2. Then up 1. Then up 1. Rinse and repeat. 1, 2. 1. And 1. And we can weave our rails around. Let's come into the front. Into the front. And technically that can go straight, but we'll just make everything uniform. We'll use our regular wave pattern to bring all these through. Perfect. Connect up our inputs. Oh, come on. That's totally valid. See? Gotta do it in the right order, I guess. So we do middle, then left, then right. Oh. middle, left, and right. That's a bit too far away. Middle, left, and right. Okay. I guess let's get this first row running. So we're going to set these to... Oh, we do need to create some powder, don't we? This is not raw calcium ore, it's calcium powder. So rather than dispatch the calcium directly, I think what we'll do... We'll use this one. We should be able to provide all the calcium powder that we need from a single one of these. Because these are producing 8 every 2 seconds, and we basically need 6 every 2 seconds worth of calcium blocks to produce the amount of calcium powder that we're going to need. So we'll delete this. We'll replace this with 3 smelters facing this way. We'll go back 1. 1, 2, 3. Rail connectors here, here, and here. Send this straight through. 1, 2, 3. Reapply power. We'll get these grinding away. Calcium, calcium, calcium. Collect our outputs. One, hello, 2, 3. This is what, 60, 120, 180? That should be fine. We'll feed all of this into a series of furnace V2s facing this way. One, two, three. Rail connectors here, here, and here. There we go, nothing fancy this time. Just going to make calcium powder, and calcium powder, and this will give us, this is 10 every 3 seconds. That's what, 20 cycles per minute, so 20 times 10 is 200. So this is a total of 600 out. We're going to have one that's going to split its output between 2 of these, and these are going to go to a series of 2 dispatchers, right? 240 and 240. We need 2 cargo dispatchers. I can't move. There we go. 2 cargo dispatchers. I'm kind of crushing these nodes. Don't know how much I care, though. I'm primarily going to use the high-quality nodes. So I guess let's center these. So we'll go back 1, 2. We'll put these here and here. And essentially what we need to do... Actually, I'm going to move these over 1. Just to make these perfectly center on this set of furnaces. Basically need to rail modulate this guy. We'll see how this works out. So we need a rail connector here, a rail connector here. We're going to take all of you, in, and then we're going to split you between these two. So this is going to be 200, 200, and this is going to be split 100 and 100. So we'll have a total of 300 into each of these. And this is going to give us, technically, theoretically, this should do 300 because it's every 20 seconds it sends a full stack. So that's 3 cycles per minute times 100. theoretically it's a cap of 300 per minute, but realistically it gives you closer to 240. But that's all we need, 240 and 240. And that should be the exact amount needed. Each row of our compounder V2s is going to be pulling the entire output of one of these dispatchers. So let's get these named. We'll call this calcium powder for PHE31. Calcium powder. Whoop. And then C powder 4 PHE3 2. Why not? Okay, back to our cargo receivers. We're going to set these up to pull down not our C powder, but our helium and sulfur. And you'll see I did actually add an additional, I basically doubled the amount of extractors that we had on dispatchers, because we're doubling the amount of compounder V2s that we were planning on having. So we're going to start at helium 3, I suppose. So we'll take TX17. And up here, we'll take TX8. I guess we missed one. We're going straight to 19. And then we'll take sulfur 15 and sulfur 14. We'll set this to helium 3. We'll set this to sulfur ore. And now we'll pull in our C powder for PHE31. Calcium powder. So that should be 240, 480, and 480. Let's set our recipes. This one's already set. Pressurized helium. Pressurized helium. And looks like this one's already set. We'll just wait for all of our materials to come in. There's 2. There's 3. Beautiful. So any minute now. Alright, there's our compounder V2s in action. We got the magic smoke coming out. The good kind. As you can tell, it's white magic smoke instead of black magic smoke. That means it's doing its job. Beautiful. So we just need to duplicate this on top. And look at him go. So for now, we'll collect this into a storage depot V2. And these are producing 150 each. So we're actually going to have to split this into 2 rails. So we can do 150, 300, 450. And then the same thing here, 450, and then we'll have to split, I guess, these 2 into a separate batch. Let's see. Rail support. Rail modulators. This way. 1, 2, 3, there's 300. Like so. Then we'll bring 1 rail support down. And how do we want to do this? I guess we actually want this to be a rail modulator because we're going to need to bend this around. We'll bring this down 1. And then we'll put a rail support here at full height. Because we're going to bring this down 1 so we can bring this forward. So now we have... That's straight? That's straight. Now we have 150 here. We have 450 here. We'll bring this directly in here. We go up. Well, this will be at regular height, right? No. Oh, this is too small. This is too low. I'm like, why is that? Why is that level? That shouldn't be level. It's because this is down 1. So this should now be level. We'll bring this into here. Maybe do this. And then we just need to bend this into here, or catch this with a rail modulator 5. Will this go into here? It will. So we'll send this around. Oh, that's full height. Whoopsie. Modulator 5. Down 1. Or we could do it with 3 and just make it completely straight. Rail modulator 3. Down 1. I'm being finicky, I know. And then this would be a rail connector at full height. Into here. Then this can go here. This can go here. Everything is perfectly straight. And then we'll just let the we'll let this storage depot V2 do our joining for us. So we'll set this to pressurized helium. Here it comes. Okay, let's work on our second deck. We're gonna need to bring some major pillarage in here because we have to get an additional 2 cargo receivers stacked on top of our existing stack. So we're gonna do, this is gonna need an additional 3 offset. So this is gonna be at level here and here. Then 1, 2, 3. I think that should be enough to stack our next cargo receiver. It is. And then we're gonna need an additional 3 offset from here. So this is gonna be 1, 2, 3. Like so. And this might be interesting. We'll have to see how this shakes out. Yeah, that's gonna be... We need more support, which we can get if we delete this set of pillars now. There we go. And we change all of these to +3s. Stack it up. And we do platform, platform. As long as this has 4, it does. It has 4 adjacent tiles of support, which means we can put an additional cargo receiver on there. So we're going to duplicate that for this side now. We need at least one of these to be at level. 1, 2, 3. Put a platform. Bring this up. Gonna need one more. One, 2, 3. Platform. There we go. Now we need our outer platforms to be +3. Pillar, 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 pillar. So let's get rid of... Oh. I cannot get rid of that for some reason. Whatever. That's fine. It can stay there. We'll bring that all the way up. And we know we're going to need to bring this all the way up as well. So now we should be able to get rid of these pillars. Huh. Well, how does that make sense? This is routed into here. This should be more than enough support. Let me put a temporary pillar or maybe a permanent pillar on this side. 1, 2, 3. We'll bring this up. 1, 2, 3, 4. Yeah, that doesn't make any sense. I should definitely be able to delete that. I should have enough support between it's connected to this adjacent, it's connected to this pillar, it's connected to this pillar, it's connected to this pillar. That should be way more than enough support for this. Here, let's do this at the exact offset required. So we'll do this at level 1, 2, 3 platform. It'll let us do that. Now we can delete this for some reason, and we can delete this for some reason. So now we're back to what we originally were trying to do in the first place. Whatever. So let's delete these. And then we'll duplicate this. Oh. I got bounced. We'll duplicate these at +3. Pillar supports. All the way up. 1, 2. Drop this on top. There we go. And we need one additional receiver right here on the end. I'm a little annoyed that that's not at this level, but with how high these are already, I don't know if we can push an additional pillar or two on top of this and still have 4 adjacent tiles, so we'll just have to live with a little bump up. So we'll do one more of these. This is going to be at +3. No, that's at level. Right here in the end. 1, 2, 3. Platform. Let's see if we can get away with this. We can. So we don't need this at all. We'll get, just to make sure nothing else is going to be deleted if I delete this. No. We'll get rid of this. Everybody's happy. Now we may need another pillar here on the end to support this storage depot. So let's put one there. At level. 1, 2, 3. Platform. Now we can copy our storage depot here. Now we are actually going to need that for all of these. Here and here. 1, 2, 3. 1, 2, 3. Lock our Z. Here and here. Rails out. 1, 2, 3, 4, and 5. Okay, now let's set up. Where am I at? Physically, let's set up our rail supports. So we'll have a rail connector down 1, 2. Lock our Y, or lock our Z. We'll do 1, 2, 3, and 4. Bring this back in, go up 1, lock our Z again. I've learned to use the machines themselves, use their footprint to prevent you from having, when you change the railhead height on any kind of rail, if you're floating up in the air, it will reset your height and you'll have to mouse wheel it all the way back up again. If you just move your mouse over so that you're on a shelf here, then you can change your railhead height without having to reset the base of your rail height. There we go. 1, 2, 3, 1, 2, 3, 1, 2, 3, and oops, I completely skipped this one. That's okay. Down 1, lock our Z, like so. And then from here, we're going to need rail supports. And I guess this is going to be a little bit interesting. Let's see how this shakes out. So we're going to go to here, rotate. This is going to be down 1, 2, technically. Even though it's going to be ramping up, but we'll see how that works. We have 1, 2, and 3. Let's see if this works first before I connect everything up. So if we S-curve this up like so. Hey, that works. Okay. That's all I needed to know. Loop these out. Wave these through. Okay, there's our main bus, and then we'll bring these up. We have to do middle first, middle out, like so. Okay, all hooked up. Let's set up our receivers. We know this is going to be helium-3. We'll take 20. And 21. Sulfur, we'll do 17. And 16. Set this to sulfur. Helium-3. Set this to our other sea powder 4. PHE3 2. Calcium powder. While those are buffering, we'll set our recipes for pressurized helium times 4. Here it comes. There we go. We're pressurizing, or I guess compounding. Beautiful. Okay, we're going to collect our output in the same way. So we'll do a rail support here, then a rail modulator here and here. And then on the bottom, we've got what? A full height rail module. No, it's actually down 1, so this is below. And then a rail support at full height past that. And this comes down into this. Bring these through. Like so. Okay, so we've got 450, 450. All right, and we have an extra 300 here for a total of 1,200 that we need to split into 5 cargo dispatchers, which will be 1,200 divided by 240 is 5. So that'll be exactly enough. But this is going to have to be stored in, I guess, 3 storage depot V2s because these are. We're auto saving. We'll basically have, what, 480, 480 is 960, and then the extra one will have 220. So we'll collect all these into Storage Depot V2s first, and then we'll do a little rail balancing to split that 5 ways evenly. So let's get Storage Depot V2 again. How do we want to do that? We'll go... I suppose we can go up for the moment. Just gotta figure out where I want to do our rail balancing. I guess our 5 dispatchers will be here in the front, so we can do our rail balancing in the rails leading up to that. So we'll copy this layout. So we had a rail modulator 3 facing this way, down 1. Lock our Z right there. And we brought this rail through first. And we did a rail connector, even though it's not really necessary here because we don't have to go around any pillars. We'll put this right here. And then this goes in the side. This goes in the front. There we go. So we'll set this to collect pressurized helium. Nom nom, gobble it all up. Okay, so now we've got... This is technically too much. But we have 2 rails, we have 2 outputs that can both support 480 here. Okay, I've changed my mind. I want to rail balance this before it goes in. Basically, I want to have 3 available outputs to go straight to our dispatchers so that we have a dedicated rail per dispatcher since we're going to be sending 240 through each one. So basically I need to take this extra 100 here and split it between this 450 and then combine, moving on to combine with our extra output. So instead of doing it like this, what I'll need to do is interrupt this line, bringing this into a rail modulator, which we're probably not going to be able to do with this type of bend, but we can do if we put a multi-rail 3 here. You can go from here to here, and then from here into here. And then we can take one of these up into here, send the other forward. We don't need to bring this into here anymore. This is already going to take 450. So basically, we have 450 on this rail. Then this rail here is sending an additional 150. We're going to get 30 on this, combine 30 with 450 to get a total of 480 on the output going into our storage depot. And so 150 minus 30 is 120 is going to continue on this rail. And this 120 is going to combine with that 120 to form the extra 240. So we'll have 480, 480, and then 240, and those will add up to 1200, which will then divide into 5 cargo dispatchers. So we'll do that again here. So we need a multi-rail support. Well, first we have to delete this. We need a multi-rail 3, down 1, lock our Z right here, then a rail modulator, down 1, lock our Z, nope, that's locking our position, lock our Z right here. So we'll take this, send it around, send this into our modulator, send one output up this way, send the other output forward. We'll take this away. And then, so now we have 480, we have 480. I just need to get these two together somehow. Rail connector. Lock our Z. One here. One here. We'll go up. And down. Here we go. Now we have 240 here. Then we just need to bring everything forward. So we'll do, I guess, multi-rail 5s now. We can finally make use of these. We'll bring this down 1. So we'll grab... See, I want to send this instead of into the side. We'll do this into the front. Because I want to use those back outputs. So we're going to grab, I guess, 2. I guess we could have left that up the way that it was. We'll do 2. Yeah, that's fine. 2 from there. 1. Really? Oh, I guess I need to put this in the front a bit. Rail support. That should work. Stop. We've got so many of these. You go... What? Go there. Then go... There. Then... You... Go there. Perfect. Okay. There's our 5 rails with 240 on each. And we're going to bring those into 5 cargo dispatchers along the front, which are way up in the sky for some reason. This is going to send us way over our thermal limit, though, so I think what I'll do is I'll wait until after the rupture so that I can build up a tower of base core amplifiers, and then we'll have enough thermal capacity for our 5 dispatchers, and then we'll be done with this factory that I don't know how much of this we'll even actually need, but I wanted to do a new factory build with all the cool stuff that we unlocked, so I'll see you guys in just a minute. Okay, now that we have all of our output evenly divided onto 5 rails and collected onto a multi-rail 5, it should be pretty easy to turn this into a distribution rail. So I'm going to lock our Z at the height of our machines. We're going to go diagonally from here, 1, 2, I'm going to go out 1 additional time just because I don't want the bend on these wave patterns to interact or get in the way of our outermost rail here, so we'll put a gap of 1 in between the two. And because we're at a diagonal here, this should make a nice, pretty looking curve. A nice quarter circle. Like that. And now all we have to do is drop down 5 cargo dispatchers. Starting, I guess, here. 1, 2, 3, 4, 5. And we'll simply bring our multi-rail 5 through. We'll put 1, 2, 3, 4, 5 in those locations. And then we just connect up our rails. So this will go here and then break off. This will flow through and then break off. And so on. Break off. This one. Number 4. All the way through. And break it off. And then finally, number 5. Gorgeous. Okay. So we have 5 dispatchers full of pressurized helium for some reason. We are going to use some of this to make liquid helium, which we're going to need for sure in finishing off our corporate levels. Not helium-3, but pressurized helium. Did I do that here? I did. Pressurized helium. Pressurized helium. And pressurized helium. I guess let's see what number pressurized helium we're up to. Oh man, look at this nice traffic flow of pressurized helium across 5 lanes. Oh baby. Alright, let's see what number pressurized helium dispatcher we're up to, so I can name these appropriately. In use. We have PHE3 TX 1, 2, and 3, so this will be 4. PHE3 TX4. PHE3 TX5. PHE3 TX6. PHE3 TX7. And PHE3 TX8. There we go. Okay. That's going to be it for this factory. I had really intended on making this. This wasn't in today's game plan, but I'm glad that I did because we finally got to use our... Well, finally, we got the opportunity to use our compounder V2s and our chemical generator. So we're going to reuse some of this. I'm not going to build an all-new liquid helium factory because it's going to require us to make an all-new hardening agent factory. That's a little bit more than I want to refactor. But we should get a good return on investment if we replace our compounder V1s with compounder V2s for producing liquid helium. So let's head over there. Okay, so let's see. We currently have 1, 2, 3, 4, 5, 6, 7, 8 compounder V1s producing liquid helium. Available to those, we have 1 pressurized helium and 1 hardening agent each from... If I can get out of here. 1, 2... just 2 receivers. And for our compounder V2s... we plop this down. Our V2 recipe is going to use the exact same amount of pressurized helium and hardening agent, but we're going to add 1 additional chemical. And for that, we get 5 every 3 seconds instead of 1 every 3 seconds. So first, I guess we're going to need to go source some chemicals. I know we have some extra, but let's go take a look at our chemical factory and see just where it is and what we're going to have to do to get it into a dispatcher. Okay, I've been watching our furnaces for a little bit here, and most of them are in use at the moment, but we have 1 pair here on the end where only this bottom one is really getting pulled from. This one has been sitting at 98 and getting completely untouched for a full few minutes now. So I think I'm going to do is disconnect this. We'll leave whatever's pulling from this particular line of chemicals here is only using a small amount. So I'm going to commandeer this output. This is going to give us 4 every 2 seconds. So that's 30 times 4. That's 120 per minute. I did not check our ratios. Well, hopefully this will be enough. If not, this isn't too terribly difficult to make, but 120 per minute should be a good amount. So let's borrow this cargo dispatcher. Where do we want to stick this? This was nice and neat, but we're gonna muck this up a little bit by adding some extra stuff here on the end. So we're gonna run you into here. We're gonna call this Chems for liquid LHE3 for liquid helium 3. How's that? Pulling chemicals. Here we go. Finally put you guys to some use. Let's head back to our compounder bay. Okay, so we don't need this entire footprint. So let's see what we're going to be replacing these 8 machines. I guess technically we can replace this with 8 compounder V2s, can't we? So maybe we do need the full footprint because we're basically using the same amount of material that we're using in the V1 recipe. Plop this back down again, but we're going to be adding chemicals into this. So we have 1, 1, and 1. This is every 3 seconds, so this is times 20. So we're using 20 chemicals per minute per machine. That's a total of 160, which is actually a bit more. We've got 120 available from our 1 chemical factory. So we can either create a second chemical factory and go all in with 8 of these creating liquid helium, or we can just cut back our expectations because this is already 5 every 3 seconds versus 1 every 3 seconds. So we're already, well, technically we're 5xing, but we're actually only getting a raise of 4 because we're going from 1 to 5. So we're only actually adding 1 onto what we're currently making. But we're basically making 5 times our original production amount. So I don't think we need 8 full machines here. Even if we just had, what, 4 of these, that would be so 20 cycles per minute times 5, that's 100. So we'd have a total of 400 per minute across 4 machines, whereas we currently have 8 machines making 1, so essentially 8 times 20, 160 per minute. That would give us an extra 240 on top of our current production. And then we'd have still these materials for these other 4. We could create a separate row of these somewhere else. So I think we're going to do that. I'm going to save real quick. We'll make a new save before we wreck this place. Okay. And then I guess let's break it all. 2, 3, 4. My main problem Well, not really my main problem, just a thought that just occurred to me is that these are going to be built on our the edge of our base course again, so there's a good chance that these new V2 compounders are also going to break at some point in the future. So we'll just have to keep an eye on it. So I'm going to scoop up everything on the rails here. It'd probably be best to destroy the rails too. I don't know how well these are going to line up. But if we can reuse them in place, that would be the quickest way to do this. Let's see what we can get away with. So we're going to make a compounder V2. We're going to put this in the spot. Oh, right, they're super deep. Oh, okay. Well, it looks like we'll be redoing our rails then, so let's just get rid of all this. Okay, so there's the space that we have to work with. Let's try this again. Compounder V2s. We're going to want to place these at this height, so we'll lock our Z here. Flip this around. We need to bring this forward enough. We need to bring it basically forward 1 to leave enough space in the back to collect all of our goods. And then we'll do 4 of these, right? 1, 2. Oh no. We're running into our dispatchers now. Can we do this? This is so ugly. Okay, well let's do this. We know we can stack these, so I guess I'll just delete these 2. We'll push this out. Is that right? We'll push this out 1. Lock our Z. Like that. We'll space this out so that we can put pillars in between. I'm just trying to avoid having to tear all these up while they're working. So we'll do a supported platform. We'll put this down 1, I think is what we were using. Lock our Z again. 1, 2, 3, 4, 5, 6, 7. Pillar supports. 1, 2, 3, 4, 5, 6, 7. Okay, there's our foundations for 2 more. Copy. Rotate. Bring her up. Lock our Z. 1, 2. Okay, 4 compounder V2s. We're going to need 3 rails technically, although what's our actual draw per machine? If we set this to liquid helium, this is 3 times 20, so 60, times 4 machines is only 240, so technically we could put everything we need on 1 rail and just loop it or split it. So if we do... We're gonna need to gather 3 cargo receivers together. Can I... if this was actually connected to that, I might be able to do it. There we go. I want to line these up correctly. I need to put platforms here, but I think this might push it out too far. Let's see. Cargo receiver. Raise. Yeah, it's a bit too much. I can put a platform, a supported platform here, raise it 1, 2, 3, and then do pillar, 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 platform. That's not right. Well, I mean, it is technically right, but not if I want to use these platforms here. I have to do another one on this side. 1, 2, 3. Then pillar, 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 platform, drag that up, there we go. So we'll need one of these here. Rail V3, I guess? Although, if we're going to combine all these into a single rail, I probably just want these to be rail connectors. One, two, and three, and then we'll go out. And then we can loop this through like this. That will work. It'll just make it like if we get to a point, which we probably will get to once we get into some of the different deep corporate tech trees, we'll probably want to expand on this because this is only going to use 240. We can technically put another 4 of these in here on these 3 dispatchers, but it will require us to move these forward, which isn't the end of the world. It's just not, I don't want to spend time on it right now. We'll probably do that like between episodes or something. And if we do it like this, we'll no longer have, will we? Does this equal exactly 240? This equals exactly 240, so we would technically have exactly 480 if we put 4 more machines in here, but we know that that doesn't really work because of the rail inefficiency, but we'll swing it for now. So we're gonna put a rail modulator here, because we need to split this and go 1 here, and then 1 lock RZ, 1 here. So we'll have 1 go straight forward. We'll have 1 go up to here. And then we can do 1 machine, 1 machine, and then modulator. 1 machine. 1 machine like so. Send these through. There we go. Liquid helium. This should already be set. Liquid helium, yep. Liquid helium, and liquid helium. Now we'd probably want to buffer these, now that I'm looking at this. If we're gonna increase our draw like to the max, we probably want these to be buffered in the front. So let's rethink this. Storage Depot V1. Storage Depot V1. Right. Oh, this one's got extra space. That's fine. We'll just do 1 on the left and 1 on the right. No big deal. You there? You there? And then you dead nut center. So then from here, we would do, I guess, a rail connector here. One. Let's do it a different way. Let's do you front, and you can go left. Then this would be, and we can do a rail connector. This is getting increasingly uglier the more we add on to this, but whatever. We're refactoring, so I'm not going to expect perfect, pretty factories. We're just squeezing it into wherever we have space. So this is pressurized helium. This is hardening agent. This is Chems 4 LET3. There we go, so I can get rid of some of this. This is hardening agent, 1, 2, 3. This is pressurized helium, 1, 2, 3, 4. Push the rest of this into the machines. No, they're full up. Okay, now we just wait on chemicals. Okay, everybody's filled up, and our chemicals, this is like the last machine, and our chemicals are filling up, so we're not going to hit any delivery bottlenecks. And these 4 machines are producing basically the equivalent of 20 times 3 instead of our previous 8 times 3. So now we have to deal with all the output. So this is 100 per machine, so we have a total of 400 here. So let's grab rail supports. I guess we'll start... Bring this up, lock this here. We'll start here, and then we'll just loop it, so we'll go rail modulator to... here. And we'll loop this down. Is that right? Yeah, this is going to loop this way. This is going to spin around this way. Like so. So this will look like this. Loop it. Bring it down. Oh, this is our old. I could have pushed this back one. I don't know if it matters or not. We'll delete this. Well, we'll just reconnect that at the end, I suppose. Where were we? Here. Join. Join. Join? Okay. That should dramatically increase our haul of over here. Our haul of liquid helium. Although this is going to be in demand for a bit because all of our dispatchers have run dry. We've probably crushed our cyclotron production. Okay, looks like our dispatchers are finally satisfied, so we can start building up some liquid helium in our storage depot. So let's go with this done for now. I guess we have the option in the future of adding more liquid helium production relatively easy. We just need to move these forward a bit. But for right now, let's go check on our cyclotron delivery. Oh, we're close, 95%. So we probably stalled that out due to cutting off the supply of liquid helium, but now that that's up and running again, we should be pretty close to getting this done. So in the meantime, let's claim our Griffith's Blue reward and see what they want next. They want ion injectors, which we do have available, and onboard instruments. I don't know if I want to steal ion injectors away right now, though, since we have a pending cyclotron delivery. So let's give this a bit. We're at 95%. Let's give this a bit to finish, and then we'll set up delivery of our final tier. This should get us to... we're clearing level 14. Yeah, it'll get us to level 15, which will be our RTSC generators. So we'll see you in just a minute. Oh, perfect timing.
I recommend finding a safe place. Great work.
Hey!
The Energy Corporation received its order. You can claim your rightful reward, as usual, in the corporate terminal. They are very happy with your services.
I cheated a little. I took half of the stack out of the RTSC generator machine and put it into the OCL. It was taking a bit too long. That's why we're 7.1k over budget. At any rate, we'll claim our 70 quartz ore, and now it's time for the grand finale, at least of Moon Energy Corporation, and that is delivering our RTSC generators. So, first off, we need to turn this machine back on. And we'll see our cyclotrons fill back up a bit. What else is coming in here? RTSCs. Okay. And we'll set this... Oh, we'll take one cyclotron back and give it back to the factory that we stole it from. We'll set this to, not this, but this. RTSC generators. What? Oh, there it goes. Of which we have 109. So I'll set this up for Moon Energy Corporation. Level 14, plus 1,000 per generator. 1.7 million points. Oh, God. You better find something to keep ourselves busy for a while.
Arcadia status.
Casual 100k. Although that was like all of our RTSE generators at once. So we're 10% of the way there. Next up, I think we're going to refactor our sulfuric acid production. We're probably going to run up the whole chain and refactor synthetic resin production as well, but to do that, we have to start here with sulfuric acid. So we currently have 1, 2, 3, 4, 5, 6, 7, 8, 9 pressurizers producing sulfuric acid, and these are doing so at a rate of 4 every 2 seconds, using 8 sulfur ore and 4 chemicals, but we can improve those numbers. If I plop down a compounder V2, somewhere where there's some space, we can be producing sulfuric acid at a rate of 8 every 2 seconds. We can double our efficiency, or our total output of sulfuric acid, by slightly adjusting our recipe. So we're going to be using 10 sulfur ore instead of 8, 2 chemicals instead of 4, and we're going to add an additional 1 wolfram powder. So I don't know if we need to completely double, because right now we're producing 1,080 sulfuric acid per minute, and if we replace all 9 of these with 9 compounder V2s, we'll be producing 2,160 per minute. But we can probably get away with doing at least, I don't know, 6 to 8 of them. We'll see how many we can get away with, but before we can tear these down, we are going to have to get some additional wolfram powder production online. We're going to need 270, which is 30 per minute per machine times 9. So if we don't end up using all of those, then never hurts to make more than you need. But if I pop down a furnace V2, let's take a look at wolfram powder. So this is producing at a rate of 30 times 10, 300. So we can do all of that with a single furnace V2. So I just need to source at least, what, 2 every 2 seconds? Probably should have kept that up. Wolfram powder, yeah, 2 every 2 seconds, so a single poor quality wolfram node will be able to produce 300 wolfram powder per second for us. So let me source that, and then we'll get these pressurizers torn down and replaced with compounder V2s. Alright, I set up a little smelting operation out by our far east base, so our far east base is on the other side of this sulfur mountain, just over in that direction. You can just barely see the base core from here, but yeah, straight to the north, there's a whole slew of pure wolfram nodes, and I have attached one of these to a series of 4 smelters into 2 dispatchers, which I didn't actually need to do because we actually already have 2 dispatchers worth of wolfram bars available. But we're going to call this W bar TX11 and W bar TX12 because it never hurts to have more than you need, right? Okay, let's get back. Alright, so let's plan out this refactor. So my plan is we're going to lose our 9th building, our 9th pressurizer. We're going to replace 8 pressurizers with 8 compounder V2s because it's going to work a little bit nicer with the ratios that we're going to be working with. So let's start, I guess, by looking at the actual physical dimensions before we get into the numbers. It's only going to be 1 tile deeper than our existing pressurizers, and it's not going to interfere, I don't think, with the bounding box for our dispatchers. Let's see. Building is not stable, so it's a stability issue and not an interference issue. So if I put, say, some pillars below this as a test, like so, can I now put a rail support, lock our Y, or lock our Z? Yeah, so we can put rails behind the dispatchers without interfering with the kind of rhinoceros beetle nose here. So that should work out just fine space-wise. I think I'm going to leave these up on stilts, and I'll keep our existing cargo receiver layout the way that it is. What I am going to do differently, though, is because the compounder V2s require 10 sulfur ore instead of 8, that means that every machine is going to be pulling down an extra 60 per minute. They'll be pulling down 300 per minute instead of 240. So we're going to need an extra 2 receivers full of sulfur ore. That means we can run 4 machines off of an additional single receiver full of 240 sulfur ore. This is 240 divided by 4 is 60, which is exactly what each of the compounders are going to need. So we're going to have 8 compounder V2s with 2 extra receivers of sulfur ore. They'll be bringing in an additional 480 sulfur ore, which is exactly 60 per machine. So I guess let's start by deconstructing the pressurizers, which is going to cause havoc with our upstream manufacturing, but that's okay. And then if we place, for starters, a compounder V2 in its place, it's got the exact same width, which is nice. So we'll have 1, 2, whoops, that popped out right at the last second. 3, and not stable. What's different? It should be the same pillar layout for every single one of these. Compounder V2. Bring it up. Oh, it's missing a pillar in the back. Interesting. That's okay. We can fix that. Just like this. There we go. There's 4. Oh god. Oh god. Stop. Why is it jumping like that? As soon as it gets to the right height, it immediately jumps like 6 more spaces. What's happening? Go here. Block our Z. There. Delete. Replace. Delete. Replace. Delete. And delete. So we'll actually have, here's one of our extra sulfur receivers right here, so we'll just need 1 additional one. But for now, let's worry about how we're going to distribute our rails, and also let's get our wolfram in here. We're going to need 1 V2 furnace here on the end, pumping out wolfram powder. So we'll drop that first, a furnace V2, right here. Let's face it in this direction. Right there should be fine. We'll bring in 1 receiver in the front of wolfram bars. Like so. And I think we're gonna have so much extra, because it's only pulling down 2 every 2 seconds for wolfram powder, 2 bars every 2 seconds, and this is gonna be providing the equivalent of 8 per 2 seconds, so 240. Oh god. So let's connect this to W bar TX8. We'll call this W bar RX8. This is not powered because we destroyed all the rails that were previously bringing power into this, so let's do this. A little bit further out maybe. I just want this space available for rails, so we'll do here. To here. There's some power. Okay, so this will be pumping out 300 wolfram powder per second, of which we only need 270. We should probably buffer this, perhaps. I don't know if it's strictly necessary, but it can't hurt to have it. We'll put this like this. We'll collect wolfram powder. That should be our wolfram bars coming in. So we should now be spitting out some wolfram powder. There we go. Okay, so we should have everything now that we need. I don't know if we'll need this anymore. We might need this one just to support this, although this is sitting on its own. I'm gonna leave it for now, it can't hurt. All right, rails. So we're gonna need obviously 3 inputs per machine because we have 3 ingredients. So let's start there. Bring this down, 1, 2. Lock our Z. We're gonna need one on every single one of these at this height. 3, 4, gotta move up. 5, 6, 7, and 8. And we'll go up 1. Lock our Z. 1, 2, 3, 4, 5, 6, 7, 8. One more. Bring this up. Lock our Z. 1, 2, 3, 4, 5. You know, we don't actually need this one, because our sulfur ore is going to be coming from below, so it's going to be looped up. So let me delete this third one. I don't know why that's there. That might have been... No, it couldn't have been existing. It must have just misclicked. Okay, let's get rid of these. Okay, so just 2. Because we're going to have chemicals coming in from this side. Although we are going to have to... I believe we're going to need 2 different rails of those chemicals. Hang on. I've goofed everything. Alright, so we've got 3 rails of chemicals. Each one of these is presumably providing 240, although I think for some reason one of these is not producing... Yeah, this one's only got a single because we pulled one off to send chemicals somewhere else. So this one we'll try to avoid if possible, which is unfortunate because on the rightmost lane will be the first one, but we can just start here. So this and this are going to have 240, I believe. Each one of those rails should be 2 furnace V2s combined. So here's 1 and here's 2. Actually, this has a 3rd and a 4th on it, so this is actually 480 per rail. Let's just double check this. This is 4 every 2 seconds, which is 120, right? 2 is 30. 30 times 4 is 120, so we have 120, 240, then 120 and 240, that's 480 combined. So we have 480 on these 2 rails, and we need a total of 540. This is going to be sulfuric acid. We're going to be pulling down 2 every 30 seconds. That's 60 per minute. And 60 times 8 is actually 480. I was calculating with 9 machines. So 480 means that we actually only need 1 of these rails. So we don't have to do what we were doing before. Right, because we had the pressurizers were using twice as many chemicals. They were using 4 instead of 2. So we'll only need 1 single rail of this to feed all our machines here, although it will be 480 of 480, so it might actually be a bit too low of a throughput. Because we know what happens when we expect a 480 item rail to have a full 480 items per minute. It never works out, but I guess for now, we'll get this set up with just a single rail for chemicals. And we'll see how it goes. I'm going to bring this down 1 to start, I suppose. We'll go... Where do we want to put this? I want to leave a space open to bring up our ore, so I guess we'll go to the left one on each one of these. So 1, 2, 3, 4, 5, 6, 7... I can't quite get 8. I'll have to move up a bit. There's 8. Okay, and then our rails are going to come all the way from the right, so we'll start there. We're going to grab our middle line, bring this up. This will be middle connection, and then we'll do our sulfur ore on the right, and then our wolfram powder on the left. So we'll send this through. Middle, middle, and middle, like that. Now we'll bring our wolfram up in... I just noticed all of these rail posts are facing the wrong way. They're widthwise, so they're wide instead of narrow. They should be like this, not this. So I'm going to have to redo this in order to squeeze some rails by it, so one moment. And there we go. Okay, I switched these to rail modulators. just because we know they're slightly more efficient. Don't want to set ourselves up for failure if we can help it. So there's our chemical line. So we're going to do in the opposite direction our Wolfram line. We're going to bring this down 1, lock our Z. We'll do it like this. And I'm just going to do one of these just so I can check if these are going to give us an issue if we're trying to wrap around. They are, but we have so much space here that I can set up a multi-rail 3 or multi-rail 5 to catch these. So if we put this here, 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 okay, it has to be a multi-rail 5. That's okay. Bring this down. Otherwise, if you don't have access to, there we go, if you don't have access to multi-rail 5s yourself, you just have to set up this track first and then come back and do your track in the opposite direction. So you have to basically have this connection existing first, and then you can place down this rail. I'll just demonstrate real quick. So if we were to have a multi-rail 3 here, bring this down 1, lock our Z, place this here. We can run this rail first, and then we can put our full height rail modulator facing in this direction, back where it originally was, which was right here. And now we can bring this way and loop this in. It would be like that, but I don't feel like tearing all that down for a second time and rebuilding it, so I'm just going to use multi-rail 5s from here on out. So we'll take this, we'll loop this back in like so, and then we'll bring this. That's not even the right distance. This should be down 1, lock our Y. This should be here. Not that that wouldn't work, but this at least has the same sweep as this one does. It looks a little better in my opinion. We're going to switch back to multi-rail 5s for now. Lock our Z. Bring this forward. And repeat. And 8. Okay, there's all of our Wolfram powder, except for the actual connection to our storage depot here in the end. Let's see if I can get close enough for that. I can. Whoop. Okay. Now we need to deal with our sulfur. So basically what I'm thinking is we've got one of the two we're going to need right here. So I'm going to have basically kind of a similar distribution rail, and we're going to join the output of each of these into a rail that runs along the front of 4 receivers. And then we'll take that combined output and send it up into each of these. So it's going to look something like a rail connector in the front. We just need to take special care to make sure that these are gated, because I don't want to use a completely through rail like this, because then that would allow, say, this receiver to be carried over into this machine, and we definitely don't want that. We want the outputs of each of these to be exclusive to this machine, just with the addition of part of the output of this. So if we take this receiver out into this connection here, we're going to need... What's the easiest way to do this? Take a rail modulator here, and of course I keep giving these a wide rail head. These need to be thin, because I need to bring rails around them. So maybe we'll start with this rail first. That way we don't have to worry about how we're going to wrap these rails around if we just put these down first. So if I lock this, we'll do something like 1, 2, 3, 4. And then if I run this rail first, I'm hoping these are far enough apart that we can put the rail connector in next to it. We rotate it like this, we can. Perfect. So then we'll do 1, 2, 3, 4. And then we'll have 1 rail support. Bring this down 1. Bring this out. Send it to the right. This will have 1 lead going up here. 1 lead from here. And then this will loop up into the center. That's perfect. Look at that. Okay. So then this will get all of this, part of this. None of this is spitting back onto this distribution line here. So this will continue forward. We'll take a rail up, a rail out, and then send our combined input into the machine. We'll do that 4 times. In. In. And that's half of the battle. So we're going to do the same thing on this side. We need an additional receiver of sulfuric ore, or sulfur ore, over on this side. So I'll copy this. Drone mode, please. I'm going to get this on the right Z level. So down 1. This rail might be an issue. Let's see. Can I put this rail down 1? Can I get this into here? I can, okay. We just squeaked by. So, yeah, we're doing the same thing. We're going to put down our rail modulators first, facing this way. Down 1. Lock our Z. 1, 2, 3, 4. We'll run our rails. So, from here to here. Take the outside lead and send it on. Then our rail connectors. Spin it. Lock our Z. Oop. Oh. Lock our Z. 1, 2, 3, and 4. Grab our rails again. Combine these together. Send it up. And there we go. Okay, I think that should be all the rail distribution that we're going to need. So let's get up top and set our recipes on our machines. Waiting for some sulfur ore. There we go. It replenishes. Look at that. And we're already full, like 3 cycles, and we're instantly full on our output buffer. So we're going to deal with our output in just a minute. Sulfuric acid. Sulfuric acid. I'm going to take this opportunity to ditch some of this stuff I've got in my pocket. Sulfuric acid chems. Sulfuric acid chems. I'm still going to have a little bit left. But as soon as the wolfram powder gets there, it'll start chewing on it. There we go. Okay. So let's look at our outputs. So each one of these is making 8 every 2 seconds. So that's 30 cycles. 30 times 8. 240, so each one of these is going to be its own dispatcher, which is pretty crazy. Not that I'm complaining. So we have 8 dispatchers worth of sulfuric acid now. So we've stepped it up from what, 1, 2, 3, 4, 5, 6. Although I know some of these are partial, so these are not full. These are not. Each one of these is not a full 240. If we look at the actual raw numbers, we were producing what, 9 pressurizers at 120 per minute. That's 1,080. Now we're running 8 compounder V2s at 8 every 3 seconds, or 240 per minute. That's 1,920. So we've almost doubled. We've gone from, what was it, 1080 to 1920? Not too shabby. So basically, we can fit 2 of these on a single 480 rail. So if we run a multi-rail 5, that should be enough because we're going to have 1, 2, 3, 4 rails of 480. And then we'll break these out. We'll run these into a storage depots, or run these into maybe our existing storage depots. Auto-saving. We'll get these back into our existing storage depots, and then... Yeah, so we need to delete this. And this. And this. We'll get these back into our existing storage depots just so that we don't have to rebuild our dispatchers. And then we'll have let's say, was it 4 total? So 1, 2, 3. We'll have a whole extra one on the end here. And then we'll have capacity for adding additional dispatchers, which we're going to need to create some of the extra materials that we're going to need for completing the other high-end corporate manufacturing ladders. So let's lock our Y. We're going to put one here. I suppose we're going to want one on the leftmost side of this, because we're going to want like a main bus of this coming through, and then each pair of these is going to add an additional level onto it, right? So I'm going to put one at the beginning of each one of these compounder V2s just to carry the main bus through, and then we'll add some additional modulators to actually combine the outputs of 2 of these machines and then bring it up onto the rail. Copy this. Lock our Z again. We have here and here. I don't know if we're going to need all of these, but we can delete the ones that we don't need, because obviously we don't need one here in between these two, because we haven't even joined these outputs yet. So we'll go down 1, lock our Z, we'll bring 1, and then a rail modulator facing this way, down 1, lock our Z. This will look like this. That's 240, and 240 is going to be 480. Actually, we don't need this on the far outside lane. Well, yeah, that'll actually work out, because when we get down, this is going to swap over to being left-hand justified. So when we're actually offloading these into our storage depots, we'll be starting on the left-hand side. So this will be perfect. We'll have 1, 2, 3, and 4, and then nothing on the inside lane. Okay, so then this will need to get brought forward. We'll probably won't need this. We'll bring this forward to here, and then we'll just repeat this. So we'll do a rail support, bring it down 1, lock our Z, put this here, rail modulator, rotate it, bring it down 1, lock our Z, like so, and then we'll just repeat this all the way down the line. So this will come into here. There's 240, there's 240, this is 480, and then we'll bring this to the next line. So both of these will go forward. 1, 2, rail support, down 1, lock the Z, rail modulator 3, down 1, lock it, bring them together, number 3, and we'll delete this. All 3 of these will go forward again. I'm stuck. I can't get the drone out. There we go. Release me! This will go all the way to the end. 1, 2, and 3. And then these guys will get the same treatment. 1. Oh, lock the location instead of the height. There we go. 240, 240, 480. That's a bit too wide. That's okay, we can put this into a rail modulator 3, bring this down, lock our height, put this here, and we'll just break this back out. And then we can go from here, or here. There we go. Okay, so there's our 4 rails, 480 each. We'll bring this down into another bus, or we'll just continue the bus. Is that bug noises? Bug noises? No? I'm not sure what I just heard. Anyway, we'll bring this down, hopefully. Inside out. 1, 2, 3, 4. And then we'll just break off one of these at a time. There's one. Let's lock our Z here. Bring this forward to here, I guess. We'll bring this down 1 just so it's at the same height. Alright, so we'll bring this forward to here. Break that off. We'll bring this one forward to here. Take that off. And then this one will go all the way to the end. Into there. Look at it all. It's beautiful. Set this to sulfuric acid. It's so much. It's so much acid. It's incredible. Okay, so we have all of our existing lines are now resupplied. We have the capacity for a lot more because I think some of these are only pulling down a few. I don't think all of them are pulling down a full. It's going to be hard to tell now because all of the buffers on the far sides of these have all been drained, so they're all going to be pulling down 100 at a time. But yeah, we certainly have more to work with now. At least another 2 outputs here of 240 each. So let's set those up just so we have them available. Cargo dispatcher. Not sure where we want to put them. We have 2 other lines available here. So we've got, actually we have 3 available because there's 480 coming into here. We've only got 1 line out. That'll be about 240. So we can do a second dispatcher off of this. We'll put 1 here. We'll do 1 here. And here. Which means we'll have to bring this out into here. This will loop around and come into this. So let's just put a rail support to keep this a little bit straighter. Right there. That works. And then we'll grab 1 of you. I guess it doesn't have to go into that. We can do another multi-rail 3. It's going to be the best looking way to do this. Here. And here. That might be a problem coming out of there. Maybe we'll move this back 1. So we'll bring out lock our Y or lock our Z. We'll bring 1 out into here. 1 into here. And then inside out. Here to here. 1 to you. 1 to you. I feel like we should have more. We went from 1080 to 19. Well, I guess that makes sense. We have 3 extra outputs now, right? So that's 240, 240, and 240, which is an extra 720. So I guess that tracks. Okay, so we'll set these to pull in sulfuric acid, and sulfuric acid. There we go. Let's check a cargo receiver. See what our next available. We've got SACD 6. Really? I guess we did a bunch of these that were specifically named because they're only pulling down like 18 per minute or something. So yeah, I guess we left off at 6, so this will be 7, 8, and 9. I forget what we called these. That was SACD, Sulfuric Acid, TX7, SACD TX8, SACD-TX9. Perfect. Okay. Well, there's our refactored sulfuric acid factory. Okay, well, for our next trick, we're going to refactor our synthetic resin production, and I think we should have enough physical space here to remove these. We currently have 1, 2, 3, 4, 5, 6, 7 compounder V1s manufacturing synth resin. I think we're going to switch this to 6, so we're currently making 7 times 20 per minute is 140 per minute. We're gonna get rid of one of these, probably this one, because I'm gonna need this extra vertical height for all of the compounder V2s because they're so tall. But this is going to give us, we're gonna be going from 1 every 3 seconds to 3 every 3 seconds. So if we go from 7 at 1 every 3 seconds to 6 at 3 every 3 seconds, we'll actually be bumping this up to 360 per minute over our existing 140. So I guess let's start off by... Well, let's start off by checking our physical space again. So if we flip this, I'll align this to this one here. We'll lock this position and lock this height. And if we look in the back, we have just enough space. We're going to use this extra gap space that I put in between each row to be our rails, our output rail collection space. So this will work out just fine. These are the same width, so they're going to fill the same width of each of these stacks. They'll just have to be taller stacks. So let's get started. I'm going to delete all of these. 1, 2, 3, 4, 5, and 6. I'm sorry to all the machines that are using synthetic resin. We might as well destroy all of these. I know all of our input ingredients are the same, but I think our ratios are going to be slightly different. Basically, I chose the 6 machine number based upon our available amount of hardening agent, because I'm trying to not have to put in another factory for more hardening agent. We're currently only using 140 per minute out of this 240 cargo receiver here. So if we were to max out the output of this cargo receiver, the theoretical output of this cargo receiver of 240, we can fit 6 machines in here evenly. So let's get rid of this guy as well. I'm just not sure if I need to redo these lines or not. I know we're going to need some more sulfuric acid, because the sulfuric acid is getting actually bumped up in usage. We're going to need a total of 600 per minute, but we are bringing up a separate line of sulfuric acid up here. So I guess let's throw down our 6 compounder V2s, and then we'll decide if we need to do something with our input rails. That can stay for right now. I do need to get rid of all these because we're going to be using this depth. There we go. So compounder V2. Right here. 1. That is not the right way around. Compounder V2s here. 1, 2, and 3. And then we're going to have to bring these up quite a bit. I guess we can use our existing pillars. We just need to add, what, 2 more? It's going to be slightly taller than necessary. But because of the weird, this is 22 vertical units high, we'd actually need to bring this down more than we have space for. It'd have to be like under the ground to get it exactly at the right height. Let's see, 22... would be 18 and 4. We can't go up 4, right? This would be 1, 2, 3, 4 is too high. So you would have to go 1, 2, 3, 4. We have to go 6 down from here. So 1, 2, 3, 4, 5, 6. That might work. Let's see. Let's get rid of this. We'll copy this. Copy this here. Hopefully... I don't think I just destroyed a receiver. I hope not. We've got 2 calcites, a sulfur. Yeah, we didn't. Okay. This will go... here. Just barely above the surface. Delete these two. And then in the place of these two pillars will be 1, 2. Lock our Z. Let's try that. We'll probably need some more, actually. The count of pillars will need to be higher, just because these things are so deep. Auto-saving. I got a confirmation of putting a pillar somewhere. I don't know where it went. Oh, there it is. How does that happen? That was placed through, like, other geometry. Anyway. 1, 2, 3, 4? 1, 2, 3, 4, which will technically be 5 high because these are resting on a supported platform. 2, 3, 4. And this should be the exact height needed to put another one on top. Flip it around. Yeah, we're gonna need some more pillars. So let's do... I'm just curious how few we can get away with to save us time repeating this. We'll try 2 in the middle. Like that. 1, 2. 4 pillars on top. 2 platforms. Lift this up. Hey, there we go. Okay, so we can get away with 4 pillars on each side. So let's do that. 2 more times. Okay, there's our pillars. Let's bring these up. Flip it around. Lock our Z. 1, 2. We're gonna need some more power, which is fine because we can replace one of these wind turbines. Maybe one that is not contributing to the deck. Yeah, that's kind of all of them. We'll delete you. Replace you with a chemical generator. It's going to put us way over budget for power. Lock our Z. Bring this out to here. Supported platforms. Yeah, let's just go all the way around. Safety barriers. And fill in the gap. Look at that. We have more than half of our reserves available now. Why is that? Oh, that's open because we refactored that. That was liquid helium. Okay, back to work. So we have all of our compounder V2s in place. So let's look at our ratios. Duck under here. So if we're making synthetic resin, this is going to be every 3 seconds is 20 cycles per minute. We're going to be using 2 times 20 is 40 per minute of hardening agent, 5 times 20 is 100 per minute of sulfuric acid, and then 6 times 20 is 120 per minute of calcite sheets. So in total, that's across 6 machines, that's 240 hardening agent, 600 per minute sulfuric acid, and 720 per minute calcite sheets. Now we do already have this broken up from top to bottom, although our ratios are a bit different. So we're gonna have, it's basically half and half now. So let's see, the calcite sheets are not gonna change because it's the same. So we should have 2 calcite sheet receivers, 1, 2, 1, 2, yep, per row. And then we're going to need just 1 hardening agent that's going to hit everything, because this is 240 is enough to hit all these machines. So let's just trace this through. This loops all the way through. Whop, whop, whop. And then somehow it needs to get up to these 3. I think originally there might have been a loop that went back up, which is no longer there because we deleted the top deck. But I guess we can split this here and send this way as well. So hardening agent is good. Calcite sheets we know are good. The only difference is going to be the sulfuric acid. Because we need 600 per minute, that means we're going to need, if this is 240, we've got one down here, this is 240, one up here, this is 240, this is 480 out of our 600 that we need. So we're going to need a third sulfuric acid receiver, which I guess we can put right here in the space where this other one used to be. So I'll delete this. Not that it's going to be in the way, it's just I saw it there, so it needs to be corrected. Lock our Z. This will go right in the middle, I suppose. Why not? We'll put another storage depot right here. So we're going to have 240, 240 is 480, plus another 240 is 720 out of our 600 that we need. So we'll essentially have to, I guess, bring this sulfuric acid to the right to feed these 3. It's not going to be sufficient, but if we continue this sulfuric acid, once we get past this third one, if we loop that sulfuric acid up and then bring it this way, or maybe we intercept it because we only have 3 inputs. So I don't think we can have one sulfuric acid coming this way and one sulfuric acid coming this way. So maybe we'll loop this up and join this onto the sulfuric acid that's already going this way, perhaps. Or we remake this one as sulfuric acid and move this calcite sheet over to this one. That's probably going to be a bit easier because then we can we'll take an output from here and loop this up into this. We'll make this like a rail connector, and then we can join this and go this way, and this one and this one will go this way. I think that makes sense. So let's do that. Let's see, I'm going to disconnect. No, do we need to disconnect it? Because this rail is backed up anyway, so I'll just take 1, 2, 3, 4. And we'll reassign this to one of the sulfuric acids we just made available. Let's say 7. We'll grab this. This is going to become sulfuric acid. We'll turn this into calcite sheets. Put 1, 2, 3, 4 of these in here. Rail V3 into here. We'll work out how we're going to get this in here in just a minute. Did I do that right? I did not. This one needs to be sulfuric acid. Whoopsie. C-sheet TX2. Give me these. This is calcite sheets. This one, I have so many calcite sheets in my pockets now. This one's gonna be sulfuric acid TX7. Okay. Give me the rest of these. We'll switch this to sulfuric acid. Grab these off the line. Okay. Then we have sulfuric acid and sulfuric acid. This will need to change slightly. We'll get rid of this and this. This is going to become a rail modulator. Down 1. Flip this around like so. We're going to grab you and send this forward. And then this is going to need to change. I guess it's fine as it is, but it's going to need to change. Now let's just send it on through. So let's delete you 3. Ah, blessed quiet. Okay. So, hardening agent is going to come all the way through. Straight to there. Sulfuric acid, we've kind of already dealt with. This is actually going to need to double up, so we're going to have to put a rail connector here. We'll need to send some of this sulfur or sulfuric acid up, right? Which we could technically... Actually, I think I prefer to do that with a separate output from the side here. So we'll just send this forward. And then our calcite sheets are going to need to be brought together. Rail modulator, down, down. 1, 2. Send these forward. Let's take these off the line. Not sure why... Oh. What is this connected to right now? C sheet T. Oh, there's that's why. It was backed up with sulfuric acid. So just so we're not wasting anything, I do kind of want to push some of this stuff in here. We've already done it with sulfuric acid. Here we'll do synthetic resin. 1, 2, 3. I just don't want all this stuff to go to waste. Synth resin. 1, 2, 3. Synth resin. 1, 2, 3. There we go. Slightly less wasteful. Give me all that. Alright, where were we? Sulfuric acid is joined. Calcite sheets are joined. They don't have a destination yet, but that's fine. We need to loop this sulfuric acid up into this. So let's turn this... Ooh. We need that, huh? What if we... put a pillar in here? 1, 2. Now we can delete this, which means we don't need this. We'll put a rail modulator here. Sulfuric acid. Send this, well, nowhere right now because I have to rebuild this upper rail system. But we need this to come up and into here somehow, which may involve putting a rail connector. Oops. How did I grab the back of that? Put a rail connector right here, and this should allow us to combine that. There we go. Then we can send this forward, but not right now. There. Not sure how I feel about that exactly. Now, we'll have one dedicated for each row. This will be dedicated to the lower row. This will be dedicated to the upper row, and then this one will share between the lower and the upper. That's fine. Okay. So, now let's hook up our lower set of machines. 1, 2, 3. I'm too far away. There's our hardening agent. One, 2, 3. 1, 2, 3. Now we need this same setup up top, so we'll grab rail connectors, bring it down 1, 2. Make sure we're facing the right direction on the rail support. Z level's locked, so we'll bring 1, 2, 3. Raise this by 1. Lock our Z again. 1, 2, 3. Raise it by 1. Lock our Z. 1, 2, 3. Now we just need to get these. This is the lowest rail. Calcite sheets, yep. This is the middle rail. This will be the highest rail. Not as straight as I would like, but that's fine for now. Oh. Hang on. Hold your horses. We have to do middle out again. There we go. We'll wave these through. Middle out. Wave these through. Middle out. And calcite sheets. Sulfuric acid. Hardening agent. Alright. So let's manage our output now. Excuse me. So this is 3 every 3 seconds, which should be 60 per minute, right? 1 every second. So we should be able to fit all of these onto a single 480 rail. So we'll grab rail supports here and here. No? Here? That's fine. We'll send these to the left, and then we'll join these at the end here to go into our storage depot. So let's do rail modulators. Here. And here. As well as here. And here. Send it to the left. Modulate it together. Copy it up top. And then bring these together into this existing rail modulator. We'll do 1 and 2. There we go. There's 360, which is a significant increase over the 140 we were previously producing. Alright, everything's going to take a while to fill back up because all the buffers on the far side of these dispatchers have all been drained dry, so this will take a bit to actually start to build up in here. Again, I'm being kidnapped. But we should have this fill up, no problem. So there's another refactored part of our compounder bay. Okay, so I've been babysitting our manufacturing lines. I did find a few places where we were falling short. We were not producing enough lenses, so I added just another compounder for lenses, and we're mostly okay there, but I did have to create some extra glass production at our base core base. I just tossed another couple of furnace V2s in there producing glass, which is fairly simple, and now we are able to keep up with our lens demand. However, we're still running short on epoxy. Most of our constructorizer factories that are using epoxy are running at like 60 to 70% efficiency, so we're not keeping up 100% efficiency on our RTSC generators. I did try sticking an extra compounder in here and just pulling off of the existing lines, and it helped a little bit, but it's really not solving our issue. So instead of doing that, I'm actually going to just create an all-new line of epoxy. So I'm going to delete this because it is draining our gothite powder production a bit. I'm going to delete this, as well as all of its supports. There we go. And I'm going to go forward a bit and just find a place that I can tuck this into, maybe right here. We're definitely going to go overboard on our heat, but we can always add some more base core amplifiers in here. But essentially I need 3 compounders, well, 4 compounders for epoxy, and I'm going to need at least 1 compounder for gothite powder. So let me toss down a compounder. And where can we do this. Maybe we do... Just gonna find a place where I can squeeze in the extra 3 cargo receivers. We should be able to actually maybe go past this a bit. There's some more extra space down in the end here. Here we go. So a compounder. Let's say right here. That's fine. A compounder right here. And if we're going to make some gothite powder, 4 every 2 seconds, this is going to take 1 gothite ingot, 1 pressurized helium, and 1 calcium powder. Now, luckily for us, we did just make a whole boatload of extra pressurized helium, so we have tons of that available. So let's see, at 2 seconds, that's 30 cycles per minute. But the figure that's going to be more important is actually our epoxy demand. So let me plop one of these down just for a reference, because we want to build 4 more of these. We're going to need to satisfy these numbers. So 4 compounders drawing 3 gothite powder at 20 cycles per minute. That's 240 gothite powder per minute. So we'll delete this. So we need to make 240 gothite per minute with our compounder factories here. So this is going to be producing 120. So we're going to need 2 compounders to drive those other 4 compounders. So let's get an extra compounder in next to this. There's 2. Let's plop down 3 cargo receivers. 1, 2, 3. We'll set this to gothite powder. This one's already set to gothite powder. How do I have gothite powder? Where did I... Oh, I deconstructed a compounder making epoxy. That's right. This got up a bit high. Not that it super matters. But if we can make it flat, I'd prefer it flat. Now, we'll probably want to buffer these, so let me move these back. One, two, three. There we go. There's our 3 cargo receivers attached to 3 buffers. That's going to be feeding our 2 compounders. There's all of our rails hooked up. Now we just need to set our cargo receivers. So we're going to need to pull in gothite ingots. Gothite ingots TX7. We'll set this to gothite ingots. We're going to need calcium powder. C powder TX5. We'll set this to calcium powder. And then, what was our last ingredient? Pressurized helium. One of our many, many pressurized heliums, TX5. Set this to pressurized helium. We'll name all these. Gothite ingot, RX7. C powder, RX5. PHE3, RX5. There we go. We have 2 compounders making gothite powder. We'll collect the output together. And 120 for a total of 240. Right? 2 is 30 cycles times 4. 3 times 4 is 12, so 120. Okay. Now we need 4 compounders making epoxy. So I'm going to probably just squeeze these in over here, and then we'll just run a rail, because we're a little tight on space back here. And that elevation increase here, going to make squeezing these in here a little bit of a pain in the butt. So we'll build over here where it's flat. We're going to need 2 cargo receivers, and then we're going to loop this out into our epoxy machines. Lock RZ, slide this up 1. What's the furthest we can go to the right here before it starts to complain? Right here. So let's do this. 1, 2, 3, 4. That's fine. We're going to collect all of these together. We know this is less than 480 because we've already set this factory up once before. But that's okay. Let's just double check. Epoxy, this is 2 every 3 seconds. That's 20 cycles per minute. Times 2 is 40, so 40, 80, 160. So, we're gonna need 2 cargo receivers. And if I remember correctly, I think we have gothite powder running on its own rail because it's relatively higher draw. So we'll do 2 cargo receivers, wherever we can fit them. Lock our Z there. Now, why can't I put this at the same height, but I couldn't put a compounder here? Oh, because of that? Well, this looks high. This looks like it's higher up than this. Whatever. Well, not whatever, because I kind of want to buffer these, so we will need to bring these up 2. Buffer in the front. Rails out. And then for our gothite powder, I guess we could have run it this way, but it's fine. We'll just loop it around and we'll send it in the opposite direction from our other incoming ingredients. Grab a rail. Let's bring this down. Lock our Z right here. We'll wrap this around the corner. Like so. So we'll come down around the corner, across, wrap around again. There we go. Now we'll go in this direction. Bring this down. Lock our Z. Black.
Detected. I recommend finding a safe place.
One there. One there. And one there. We'll bring this through. Connects up one to the machine. And we'll take the outside lane forward. That way we can put another rail going in this direction in the same row. Outside lane forward. And here. There we go. One more time. Not quite done. Outside lane in. This to the machine. I think that was a bit forward. That's okay. And then in the opposite direction, we'll have a rail modulator at full height going like this. And like this. That way we can do one out into here, and then one forward. So we'll do that. We'll continue that after the rupture. So I'm going to build a quick hab, and I'll see you in just a minute. Okay, so there's our rails all hooked up to our 4 compounder V1s. Let's get our receivers set up. We're going to pull down some of the extra resin that we just set up production for, which is going to be on Resin TX4. We'll set this to synthetic resin. And we're going to pull down some of the extra liquid helium, which I did not put up a dispatcher for, so give me just a moment. This one will be for liquid helium 3 for Epoxy 2. We'll call this LHE3 for EPXY2. This is Resin RX4. We'll set this to liquid helium, and we already have our gothite powder coming in from over yonder. So, this should handle itself. Now all we'll have to do, I said our cargo dispatcher, or cargo storage depots. Set our storage depots, so now all I have to do is get this rail all the way back over to that storage depot in the distance. So I guess we'll run this up along the top. If I put a rail support here in the back. Lock our Z. One here, and if I convert this into a rail modulator. Yeah, rail modulator should be just fine. This into here. This will go forward. And we'll just bring everything else forward. So from here to here. And that should be it. There's our extra epoxy. Let's just make sure this one did not get a recipe set. I didn't see anything coming out of the back of this. That would explain why. Let's fill this up with the stuff in our pocket. Okay. You need to be set to epoxy as well. Okay. That should be it. Finally, these things are operating at 100% now. And it looks like our constructorizers for anti-radiation covers are operating at 100% now. Perfect. Okay, that's one shortfall taken care of. We've got under 10 RTSC generators remaining, and we've had multiple 2s delivered so far, so this could be the final one. Is it? No! Wait, we're at 1.07 of 1.07. What is this? They're obscuring numbers. Why? And why would it not be a round number? This is an outrage. They're just rubbing it in at this point. It's gonna be 1.07999. Oh my god. The tension, the suspense. Come on, man, let me off the hook here. No, another 2K. And still, it's not the end. It's weird because this is producing them at 20 seconds and this is delivering them at 20 seconds. I think, just based on these being out of sync, I think it's like sneaking one extra one in the last, like, percent of this being delivered. Because it should be a 1-for-1. But there's just slight enough of a delay on the OCL that the facturer can sometimes sneak in an extra one. Yes! Finally!
They would also like to congratulate you. As members of the Moon family,
The Moon family?
The prestigious National Fairtrade Green Energy Peace Award.
I feel so honored. Look at that. It's commented out. We have, oh no, the next level is infinity. Deliver infinity points. Does it still take? You can still deliver them. For what? Who knows? Let's see, we have 80 of infinite. If we deliver one, oh, it's just not taking them anymore, okay. Wait, no, we can tell it to take more. So what happens now? I guess now it's just a high score generator. Yeah, now it's 1080. Okay, well, we're not gonna just needlessly give Moon Energy free stuff, especially if they're holding us hostage. Okay, so we're gonna turn this off forever. We have a significant number of extra materials here, but that's fine. I think that's what we're gonna call it for this episode. Finishing 1/5 of our corporate ladder is a pretty good accomplishment, although I was not expecting it to take... We're over 5 hours, coming on 6 hours, just to deliver the final level. That's not even for the 3 levels that we delivered in this episode. I have a separate recording from yesterday where we got through the first 2. But we had some inefficiencies in the manufacturing process that we had to iron out in order to really get that last level delivering at the correct clip. But now that it's done, we can say that we are one step closer to finishing the game. So, what do we do in this episode? We refactored literally all of our compounder V2 lines, right? Because there's only 4 recipes in a compounder V2. Pressurized helium, sulfuric acid, liquid helium, and synth resin, and we refactored all of those. So, good on us, I suppose. So we don't have to, well, I don't know if we're not going to have to worry about any of those in the future, because we could run into some shortages depending on what the other 4 corporations, what is it? What the other 4 corporations are going to need, but we should be in a pretty good position to deliver. So what we're going to do in the next episodes, I think we'll move on and refactor our high-end manufacturing towards Clever Robotics. I think is the next closest one, not to actual completion, although they are pretty well along or level 11. But as far as the actual number of novel materials we need to manufacture, new items we need to set up factories for, is the smallest for Clever Robotics. So I think they'll be the quickest to get to level 15 or 14, whatever their highest level is. So we'll take care of that in the next episode. But yeah, feeling very accomplished for this one. If you've made it this far, then thank you for watching. If you're enjoying this playthrough of StarRupture, hit like and subscribe. If you want to check out StarRupture for yourself, head on over to Steam and pick it up. And if you want to let me know what you think of the game so far, then hit the comments down below. But whatever you do, I'll see you right here again in the next one. So, until then, bye-bye.